When you look at a classic world map, the one hanging in pretty much every elementary school classroom, you're actually looking at a massive distortion.
Right, the Mercator projection.
Exactly, the Mercator projection.
Yeah.
And it stretches out the top and the bottom, making certain regions look just massive and central while physically shrinking the appearance of others.
Yeah, Greenland looks like it's the size of Africa.
Yes. And you grow up just accepting that this is what the physical globe looks like. But then one day you see a geographically accurate map, like the Gall-Peters projection, and suddenly your entire perspective shifts. You realize the center of gravity is not at all where you thought it was.
Well, and that distortion is actually baked into the infrastructure of how we navigate the globe. I mean, you build entirely different geopolitical strategies, entirely different supply chains. When a map tricks you into thinking the world is proportioned a certain way, your baseline assumptions about where power and resources sit are just fundamentally warped from day one.
Absolutely. And welcome to the deep dive. Today, we are applying that exact same lens to artificial intelligence. We're looking at a fascinating study that argues our entire definition of ethical AI is operating on a distorted projection.
It really is.
The research is titled Responsible AI and the Majority World, and it's authored by a team at the Responsible AI Lab, or RAIL, at the Kwame Nkrumah University of Science and Technology in Ghana. And they're pointing out a massive, massive blind spot in how the technology of our future is being engineered.
Yeah, because we are currently seeing this global obsession with AI frameworks. I mean, you cannot open a tech journal without reading about algorithmic fairness, transparency, data privacy, or alignment.
Right, it's everywhere.
But the problem the researchers identify is that the rules for what makes AI ethical or safe are being written almost exclusively by and for the minority world.
Meaning the West.
Exactly. Silicon Valley, European regulators. And in doing so, these architectural frameworks are completely ignoring the infrastructural and cultural realities of over 80% of humanity.
Okay, let's unpack this. Because whether you are a machine learning engineer writing the actual code, or a policymaker drafting data regulations, or, just someone listening who is insanely curious about the systemic architecture of our future, this deep dive is going to completely reframe how you think about what good technology actually looks like.
It really flips the script.
It does. And to understand the structural mismatch, I think we have to start with the demographics and the terminology, right?
Yeah.
The study uses a very specific term, the majority world.
Yeah, so that term was originally coined in the 1990s by Shahidul Alam, a Bangladeshi photographer. And it's a strict affirmative demographic reality. We are talking about the populations of Asia, Africa, and Latin America.
Which is a huge chunk of the planet.
Over 80% of the global population. And the researchers explicitly chose this term over other common labels that get tossed around in international development, like Global South or developing nations.
Right, because Global South is constantly used in policy circles to highlight post-colonial political histories and socioeconomic gaps. It kind of points to the historical power imbalances.
Yeah, and developing nations is basically an economic deficit-based metric. It categorizes a country entirely by what it currently lacks on a Western industrial scale.
Like whether they have a certain GDP threshold or widespread broadband infrastructure.
Exactly. What's fascinating here is that shifting the terminology from developing nations to the majority world forces a total reset of the technological baseline.
How so?
Well, when you use deficit-based language, you automatically frame these regions as passive recipients of Western technological aid. You treat them as edge cases in your software deployment.
Oh, I see. Like an afterthought.
Right. But by centering the demographic weight, the term asserts that these nations are not the edge case. They are the primary stakeholders of the human race. You design for the majority first.
Okay, I get the psychological shift for sure. But I do have to push back a little on the material reality of this because agency and framing, they don't buy server farms. If you look at the AI readiness index that they cite in the paper, East Asia is leading the majority world. But sub-Saharan Africa is lagging significantly behind in just pure compute infrastructure.
That's true.
And the starkest statistic in the entire study, honestly, is that roughly 10 countries, mostly in the minority world, account for 80% of all global R&D spending.
It's a massive concentration of wealth.
Right. So if the vast majority of the capital, the compute power, and the patents are still sitting in Silicon Valley and Europe, doesn't majority world just sound like a polite euphemism for the people being left behind? Like, semantic window dressing doesn't change a physical power dynamic.
That's a fair point, but changing the language changes the legal and economic negotiating posture. When 80% of the planet stops viewing itself as a developing market begging for access and starts viewing itself as the primary data and labor source fueling those Western servers, the legislation changes.
Oh, the leverage shifts.
Exactly. The paper dives deeply into how that R&D gap has created a system of what they call hegemonic AI, which operates through digital colonialism. The minority world is currently extracting raw materials from the majority world to build its models.
And when we say raw materials, we're talking about data extraction and labor extraction, right?
Yeah.
Because the paper highlights the AI laundry, which is this vast hidden gig economy required to make large language models actually function.
Yeah, so picture the underlying mechanics of reinforcement learning from human feedback, or RLHF.
Okay.
An AI model doesn't just naturally know how to be helpful or safe. Western engineers might design the core transformer architecture, but to stop the model from generating toxic garbage, millions of data points need to be manually labeled, categorized, and ranked.
Somebody actually has to sit there and read it.
Right. And that grueling, manual, human-in-the-loop maintenance is being outsourced to a massive under-resourced workforce in Africa, Asia, and Latin America. They sit in high-stress data processing centers, filtering through the darkest parts of the internet for literally pennies, just to ensure the final product deployed in the West is pristine.
It operates on the exact same logistical model as the fast fashion industry.
Oh, that's a good comparison.
Yeah, I mean, the minority world gets to celebrate this shiny, incredibly expensive, highly polished final product on a tech keynote stage. But the invisible sweatshop-style labor that actually stitched the algorithms together happens in the majority world.
And it's deliberately kept out of sight to maintain that illusion of seamless machine intelligence.
Right. It's just magic.
But the pushback against this extraction is where that shift to majority world agency becomes tangible. We are seeing a massive surge toward data sovereignty. Communities and nations are realizing that their localized data is a high-value asset, and they are locking it down.
So they're fighting back legally.
Yeah. Look at the CARE principles for indigenous data governance. They dictate that indigenous data cannot be scraped without explicit community authority. And on a geopolitical level, you see frameworks like Nigeria's 2023 Data Protection Act.
Or India's Aadhaar system.
Yes, perfect example.
India has been incredibly aggressive about data localization laws. They are not just asking nicely, they are enforcing it at the API and server level. If a foreign multinational wants to process the biometric or financial data of Indian citizens, the physical servers processing that data must geographically reside within India's borders.
Right. They are strictly gating API access to foreign entities to ensure the compute and the economic benefit stay local.
Because without that physical data sovereignty, artificial intelligence simply acts as a vacuum, right? Just perpetuating historical colonial extraction at algorithmic speeds.
Perfectly said. But, the infrastructure and labor extraction is really only half the problem.
Right. There's the philosophical side.
Exactly. Okay. The study argues that because the models are built and controlled by the minority world, the ethical frameworks embedded deep within the code fundamentally clash with the cultural values of the majority of the planet.
They call it the great ethics mismatch.
Yes. Western AI ethics, think of the European Union's GDPR framework, are built almost entirely on the foundation of individual rights, individual privacy, and individual consent.
Right. Those legal frameworks mandate that data belongs to the singular person.
But the researchers point out that many majority world cultures operate on deeply collectivist philosophies. The paper highlights the African philosophy of Ubuntu, which translates roughly to, I am because we are.
I am because we are.
Yeah. Your personhood, and by extension your data, is defined by your relational network. And Latin America has the concept of buen vivir, which prioritizes harmony with the community and the environment over individualistic infinite growth.
So when you take a Western data protocol like GDPR, which requires strict individual click-wrap consent forms, and you force it onto a culture where communal data sharing among extended families or tribes is just the default assumption, the software actually introduces intense social friction.
It does. And it also changes how you have to mathematically code fairness into an algorithm.
Oh, this part was fascinating because in the West, algorithmic fairness is usually defined by statistical demographic parity, right?
Yes.
The machine learning engineer tweaks the model so it treats individuals from different demographic groups mathematically equally, trying to remove all bias. But the study argues that in the majority world, statistical equality isn't always the goal. The goal is progressive justice.
Right, and progressive justice fundamentally changes the loss function of the model.
How so?
Well, imagine you are deploying an algorithmic loan approval system or a resource allocation network in a region with a deep history of extreme caste-based financial exclusion or entrenched rural poverty. Standard Western statistical fairness dictates that the algorithm must be entirely blind to caste or historical geography. It must treat every applicant identically.
Right, equal treatment.
But the problem is, if your training data reflects centuries of structural inequality, being blind just automates and locks in the historical redlining.
Oh, wow. Because the baseline is already skewed.
Exactly. Progressive justice requires the engineers to actively tune the model's weights. You intentionally introduce a mathematical offset to favor the marginalized group. You are not aiming for a neutral baseline. You are actively using the algorithm to dismantle the historical disparity.
That is such a different way of thinking about code, and the mismatch extends to how we evaluate transparency, too.
It really does.
Because Western regulations are obsessed with explainable AI, they want the code to be open source and interpretable so an auditor can see exactly how the neural network weighted a specific decision.
Right, looking under the hood.
But in regions with low digital literacy, handing a community a repository of open source Python code is entirely useless. The paper stresses that what these communities actually need is transparent intent. Who owns the servers? Who is profiting from this deployment? What is the supply chain of the hardware?
Because process transparency builds institutional trust far more effectively than technical interpretability, especially in regions where multinational corporations have historically operated with zero local accountability.
I need to hit pause on this collectivist data approach for a second, though.
Sure.
Because if we abandon strict Western-style individual privacy rights and we view data as a communal resource, doesn't that make it incredibly easy for authoritarian governments or corrupt multinational companies to exploit vulnerable populations?
That's a common concern.
Right. Like, if the individual doesn't have the legal right to revoke their consent and delete their data, how do you protect minority groups or dissidents from state surveillance?
This raises an important question, and it is the exact tightrope that localized AI governance has to walk. The authors are absolutely not suggesting that human rights are irrelevant.
Okay, good.
What they are pointing out is that the mechanism for protecting those rights has to match the cultural architecture. Relying on an individual to read a 50-page terms of service agreement they don't even understand is a terrible defense mechanism.
Nobody reads those anyway.
Exactly. So instead, you look at structural models like national data trusts.
How does a data trust actually function under the hood, though? Because it can't just be a board of politicians making decisions.
No, it relies on federated learning architectures and cryptographic gating.
Okay, break that down for me.
So instead of a foreign tech company vacuuming up raw citizen data into a centralized cloud in California, the raw data stays on local servers governed by the trust. The tech company sends their untrained model down to that local server.
Oh, the model travels, not the data.
Precisely. The model trains on the data locally, and only the updated mathematical weights, the learned patterns, are sent back to the global network. The actual human data never leaves the community's cryptographic perimeter.
That's brilliant.
The trust dictates the API access via smart contracts, ensuring the community gets compensated for the compute and the insights without ever exposing the raw, vulnerable data of its citizens. It protects the collective through engineering, rather than relying on hyper-individualistic legal forms.
That structural engineering becomes even more critical when we look at the physical limitations of the majority world. Because this mismatch isn't just philosophical, it collides violently with physical reality.
It really does.
The study notes that as of 2019, internet access was at 44% in these regions, compared to 87% in the minority world. If you engineer an AI system that requires constant, high-speed, synchronous cloud connectivity to function, it is literally going to crash for half the planet.
And the environmental footprint of AI compute is an even more pressing physical barrier. I mean, training and querying large language models requires staggering amounts of energy and massive amounts of water to cool the data centers.
Right. Servers get hot.
Very hot. And hyperscalers utilize a technique called geographical load balancing. AI networks dynamically shift their heaviest compute tasks across the globe to whichever data center has the cheapest energy at that exact millisecond.
Just bouncing the load around.
Yeah. But if a hyperscaler suddenly routes a massive training load to a server farm located in a water-scarce region of the majority world, The cooling towers will pull millions of gallons of water from the local grid.
Oh my God.
You are literally draining drinking water from a vulnerable population just to train a chatbot thousands of miles away.
Importing Western AI ethics into the majority world is like installing a highly sensitive smoke detector in a kitchen designed for open fire cooking.
That's a great analogy.
You know,
Right.
like the device is working exactly as engineered, it is doing what it was programmed to do. But because the engineers completely ignored the physical reality of the local environment, the device just becomes a constant, useless alarm that the community eventually rips off the ceiling.
And if we connect this to the bigger picture, it explains the fundamental priority shift the researchers are demanding. In the minority world, the primary ethical goal of AI is often harm avoidance. The engineers are trying to ensure the algorithm doesn't inadvertently discriminate, violate a privacy statute, or generate offensive text.
Right? Play it safe.
But in the majority world, the primary ethical mandate must be beneficence.
Beneficence, meaning the technology must do actual tangible good.
Specifically, it must align with the UN Sustainable Development Goals. When you are deploying technology in a low-income population, distributive justice will always trump abstract debates over machine learning bias. The technology has to secure food, water, and medical access, or it is a failed deployment.
And the study provides some fantastic examples of what this looks like when the mechanism is built for the actual environment. Like in Kenya, a platform called Hello Tractor uses predictive analytics and machine learning to route limited agricultural machinery to smallholder farmers exactly when weather patterns dictate they need it.
It's an algorithmic deployment directly targeting zero hunger.
Exactly. And in Ghana, they're using AI to route medical drones, calculating wind patterns and payload weights to drop supplies into areas where the physical roads are washed out.
Yeah, and the I-Verify system in Zambia is another brilliant example of localized engineering. During elections, they needed to detect hate speech and political misinformation to prevent violence.
Right, which is huge.
But standard Western natural language processing models, which are trained almost entirely on Californian English, completely misclassified Zambian dialects and localized political slang.
Of course they did.
The local engineers had to physically fine-tune the large language models with localized dialect data so the AI could actually parse the cultural nuance of the threat. It is a perfect example of why you cannot just import a minority world algorithm and expect it to function.
So if importing the prepackaged systems doesn't work, how does the majority world actually build its own architecture?
Well, the study lays out specific recommendations for contextualized governance. They suggest blending universal concepts of human dignity with localized frameworks.
Like what?
And like in the Middle East and North Africa, you incorporate Horma, which is the Arabic legal and cultural respect for bodily and digital sanctity, right into your data privacy protocols. In South Asia, you build governance structures around Panchsheel, which are principles of peaceful coexistence and mutual respect.
And at a procedural level, the researchers recommend replacing standard Western compliance audits with participatory impact assessments, or PIAs.
Yes, PIAs are crucial.
Because the current minority world model is to build the AI, deploy it, and then run a post-launch audit to see if it violates any laws. A PIA requires the engineering team to sit down with the local community before a single line of code is written or a single data set is scraped.
Right. The community defines the potential harms, the required benefits, and the technical boundaries up front.
They are also calling for development agencies to strictly enforce green AI standards. If an international body is going to fund a tech deployment in the majority world, the engineers have to prove the model's compute efficiency. They cannot deploy energy-guzzling legacy models that will crash the local power grid.
It requires a comprehensive reimagining of the software development pipeline, from the power grid all the way up to the user interface.
But, if we localize the engineering pipeline to this degree, if we are adapting data structures to Ubuntu in one region and Panchsheel in another, how do we avoid massive, unnavigable fragmentation?
The fragmentation risk.
Right. If every single municipality has a completely different architectural requirement for AI, how do international healthcare initiatives or global logistics networks actually function? The systems wouldn't even be able to talk to each other.
Well, the researchers clarify that the objective is not to create thousands of contradictory localized rulebooks. The objective is to establish a universal methodology.
Meaning?
Think of it like standardizing the APIs of governance. An international tech company does not need to memorize 1,000 different cultural philosophies. They just need to follow a universally mandated protocol. Before deploying in a new region, execute a contextual analysis, engage in multi-actor consultation, and establish a federated data partnership with the local trust.
Oh, I see.
The methodology of power sharing is universal, even if the specific cultural outputs of that process look different in Ghana than they do in Brazil.
Okay, that makes a lot of sense. So, what does this all mean for you listening right now? It means we have to wake up to the mathematical and demographic reality of our planet. You cannot build a truly global technology if the neural networks only recognize the cultural values, the legal frameworks, and the physical infrastructure of 20% of the people on Earth.
You really can't.
Embracing the perspectives, the philosophies, and the compute needs of the majority world is not an act of charity. It's not about corporate social responsibility or good PR. It is an absolute structural engineering necessity for the future of responsible tech.
Because if we ignore the 80%, we're basically just using advanced machine learning to build faster, highly automated engines for old colonial dynamics.
Exactly. I want to leave you with a final thought to mull over today, something that really struck me as we were breaking down the mechanics of these models. We know that neural networks learn, evolve, and weigh their outputs based on the massive volumes of data they consume. And right now, they are consuming a deeply individualistic minority worldview. But if the majority world successfully reclaims its data sovereignty, if federated learning architectures and localized communal data sets become the dominant training grounds for the next generation of models, will the artificial intelligence of the future naturally evolve to be more collectivist, more relational, and less individualistic than its original creators? Will the architecture of the machines themselves eventually internalize that I am because we are?
That is a profound possibility for the evolution of machine intelligence.
It really makes you wonder what the map of the future is going to look like once we finally take the distortion out of the projection. Thanks for taking this deep dive with us. We will catch you next time.